So we're starting into chapter 2. So we did chapter 1 at the very beginning of the year, and then we detoured into trigonometry. Now we're going to go into chapter 2. So we're in section 2.1, and we're talking about today is quadratic functions. And chapter 2 in general is about polynomials and rational functions. So, like I said, we're jumping into more regular algebra topics rather than the trigonometry topics. So, just a couple of quick definitions. I misspelled it, didn't I? Quadratic. There we go. DR, quadratic. Good thing I'm not an English teacher. There we go. Quadratic functions. So a couple of definitions. We chapter 2 we're talking all about polynomials. And polynomials are going to have the form. Polynomial function is going to be an f of x equals some number a sub n, x to the n, plus some other number n minus 1, x to the n minus 1, plus, and we have a whole bunch of these added together, and at the end, plus a1 x plus some constant, which is a0. So polynomial just means we have an equation that has all has a bunch of powers of x, in it, and n is greater than or equal to 0. So we're not talking about negative exponents, we're talking about positive exponents. So this is all chapter 2, we're going to talk about polynomials. We've talked about a couple of kinds already. If n equals 0, a number raised to the 0 power is always what? Just a number. A number raised to the 0 is just anything to the 0 power is 1. So we just get 1. So if we have the 0 power, we just end up with a constant. So we end up with a constant function. So if n equals 0, we have a constant function. If n equals 1, if our highest power on x is 1, then we just have a line. We have a linear function. So n equals 0, we have a constant. And n equals 1, we have a line. So today we're interested when n equals 2 gives us a quadratic function. See if I can get the spelling right. There we go. So that's what we're interested in today, is quadratic functions. A quadratic function is going to look like, and we're doing kind of a little bit of a review right now. F of x equals ax squared plus bx plus c. And for a quadratic function, we want a not equal to 0. So we want that x squared term in front to have a quadratic function. And we already know what does the graph of a quadratic function give us? Graph gives us a parabola. So we're going to be looking at parabolas and figuring out some things about parabolas, what they can tell us about our function. If we want to draw, I'll jump to a new page here. If we wanted to sketch a parabola, if I draw my axes here, and I wanted to sketch y equals x squared. where is going to be my vertex for y equals x squared? The origin, 0, 0. And my sketch is going to look something like this. Not a beautiful sketch, but good enough. And our vertex is at 0, 0. This point is the vertex. And the y-axis is what we call, this is going to be our, the y-axis is the axis of the parabola. So let me draw a bigger dotted line in there. So this, we call this the axis of the parabola. So our axis here is x equals 0. The line x equals 0 is our axis. So what we're interested in today is figuring out what we're going to be talking about is how we figure out the vertex of some parabola, and we're interested in the axis. Now if we know that y equals x squared, our vertex is at the origin. What if we had y equals x minus 3 squared plus 2? What does that do to the graph? Peter says it shifts it to the right 3 and up 2. So these numbers here give us a shift in our graph. So it's a shift right 3, up 2. So these give us a shift. So if I were to do a quick sketch of this graph, of the graph of this function, my vertex would be over here at x equals 3, and we'd go up 2. So if I just did a rough sketch, my graph would look the same, and my vertex would be here at 3, 2. And my axis would be here at x equals 3. So our vertex, the numbers here tell us how our vertex, where our vertex moves to with our parabola. And what happens if what would happen if I had a negative in front of the parentheses here? What would that do to the graph? What? Upside down or open, and Peter says it opens down. So a negative number here in front shifts it. And do we remember what, if I had, just in general, if I had y equals some number a times x minus 3 squared plus 2, what is that number a multiplying, what does that do to the graph? Shrinks it or stretches it, right? And it shrinks it or stretches it horizontally. So it's going to stretch it out either left or right, or it's going to compress it left or right. So the a tells us how wide our parabola opens up. And if we have a number in front a negative in front, that's going to flip it upside down. So just a quick reminder, a gives is going to stretch or compress. And this is horizontally. And a negative in front will flip the graph. Flip it vertically. So if we multiply by a negative in front, we're flipping the graph upside down. So this is just kind of review of what these different things do to what our graph looks like, what the different transformations due to our graph. So what we're interested in today is finding, if we're given some quadratic function, we want to be able to find the vertex of that function. We want to be able to put, if it's not in this form where we can easily pick out the vertex, we want to be able to put it in, we want to put it in this form so we can figure out where the vertex is. And the way we do that is by completing the square. So that's why we did a little practice on completing the square yesterday. So we're looking at, if we have f of x equals ax squared plus bx plus c, we call this the general form of the equation. And we want to get our function into a form that looks like f of x equals a times x minus h squared plus k, and where a doesn't equal 0. Our book calls this the standard form. I've never heard it called standard form very often. I'm going to call this vertex form, and that's the more common name for this one. This is the vertex form for a quadratic function. And that's what we're interested in today, going from general form to vertex form, so we can figure out where the vertex of our parabola is. For a parabola in vertex form, the vertex is at the point hk. So when we get our function in this form, our vertex is at hk, and our axis is at x equals h. So when we get our quadratic function in this form, we have a little bit of information. We have a little bit of information about our parabola. So let's look at a couple of examples of how we go from the general form, from this into vertex form. So let's say we have our quadratic function x squared, I'm going to say f of x equals x squared minus 4x minus 2. We want to find the vertex and the axis. So to change our quadratic function in this form, in the general form, to the vertex form, we complete the square. And I know you worked on this some last year as well, putting your function into vertex form. So what I'm going to do is I'm going to complete the square on the x squared minus 4x part. So I'm going to say f of x equals x squared minus 4x. And to complete the square, I add b over 2 squared. So I'm going to add, b is negative 4. So negative 4 divided by 2 is negative 2. Squared is 4. So I'm going to add b over 2 squared. I'm going to add 4, but I don't want to change the value of my function, so I also have to subtract 4. And I still have the minus 2 here. So when we're solving, it's a little different than when we solve by completing the square, because when we solve by completing the square, we add this 4 to both sides of the equation. And we can do that because when we're solving, we have a 0 here. When we're completing the square to find vertex form, whatever we add, we subtract right away. So now we're going to look at this part. I've completed the square for this part. So now I can rewrite this as a perfect square. X squared minus 4x plus 4 is x minus 2 quantity squared. And outside the parentheses, I have a minus 4 and a minus 2. So I have minus 6. And now I have my quadratic function in vertex form. So for this quadratic function, what's the vertex? Is it positive 2 or negative 2? Positive 2, because our form here is x minus h. So x minus 2, so h is 2. So our vertex is 2, and k is negative 6. This is h, and this is k. So our vertex is at negative 2, I'm sorry, 2, negative 6, and our axis is at x equals 2. So to move from the general form to the vertex form, when our quadratic function looks something like this, we complete the square using just the x squared and the x term. And whatever we add from completing the square, we have to subtract right away so we don't change the value of our function. Any questions on that part? Yeah?
What again do you mean by axis? Like where on the graph it is, like where the y-axis?
The axis of the parabola is, let me go back, is it up here? Axis of symmetry.
Okay.
It's the same as the axis of symmetry. So we can call it the axis of the parabola, axis of symmetry. So that's the part that goes right through the vertex, right up the middle of the parabola. Let's look at another example where we have a number out here in front, because that's we have to be a little more careful with that. So another example is f of x is, say we have minus 2 x squared minus 4x plus 1. And we want to find the vertex and the axis. What do we know about this quadratic function right away? What do we know about the graph right away? It's opening down because we have this negative sign on the x squared part. So it's going to open down. We know that for sure. So let's find, we need to change the form of our quadratic function to find our vertex and to find our axis. So we want to complete the square. To change our function to vertex form, complete the square. So I'm going to rewrite this. I'm going to write this as f of x, and I'm going to just do some parentheses here. Minus 2x squared minus 4x plus 1. And I'm going to put some parentheses on this part. That's the part that we want to complete the square on. We want to be able to write this as a perfect square. Now because I have this 2, this negative 2, in front of my x, I need to factor that out. So I'm going to factor the negative 2 out. I'm going to rewrite this as negative 2 times x squared plus 2x. So I just factored that negative 2 out. And I want to complete the square on this. So I'm going to say that this equals negative 2 times x squared plus 2x. To complete the square, I add b over 2 squared. Here b is 2. So 2 divided by 2 is 1, and 1 squared is 1. So I'm going to add 1. And I need to, so I don't change the value of the function, I need to subtract 1 right away. And that's inside the parentheses plus 1. So the part in red, this now is the part that I can write as a perfect square. And this negative 1 that's still inside the parentheses, I'm going to combine that with this 1 that's outside. But I have to remember that the parentheses is being multiplied by negative 2. So to take this outside the parentheses, I have to make sure I distribute that negative 2. So I'm going to rewrite this as negative 2 times x squared plus 2x plus 1. That's the part that is now a perfect square. Negative 2 times negative 1 is positive 2. So I'm going to add this positive 2 outside. Did you have a question, Cedric?
That was my answer.
Okay. So I'm just I'm distributing the negative 2 and taking that part outside the parentheses because I don't need that to complete the square. Now I can rewrite this as a perfect square. Negative 2 times x squared plus 2x plus 1 is x plus 1 squared. And 2 plus 1 is 3. So now I have my quadratic function in vertex form. So the vertex is going to be where? Let's go back to our form. Our h is the part that's inside the parentheses, though, so I don't have to worry about the part that's outside. So our vertex would be negative 1, 3. And our axis of symmetry, is x equals negative 1. Now the question, I heard a question here, why is our x coordinate negative 1? I can remember our form, our vertex form is x minus h. So I could rewrite x plus 1 as x minus negative 1. So it has to be written as x minus, we want it as x minus something. So x plus 1 is the same as x minus negative 1. So that's why our h is negative. Another question? Amelia?
Where did the 2 underneath where it says perfect square, where did the plus 2 come from?
This 2?
Uh-huh.
So when I completed the square, I added 1. That's the b over 2 squared. I have to subtract 1 right away to make sure I don't change the value of my function. I only need this part that's in red to complete the square. So I have to deal with this negative 1. So I distributed the negative 2 to the negative 1 to get positive 2 and took that outside the parentheses. So negative 2 times negative 1 is a positive 2, and I just added that outside the parentheses. Does that make sense?
Why did you just distribute it to the 2?
Because I want to rewrite the part that's in red as a perfect square. I want to be able to write it as x plus 1 squared, because that's what's going to give me my vertex form for my quadratic function. I want to be able to rewrite this part as x plus 1 squared, and that this extra number here doesn't have anything to do with completing the square for this part. It's just extra because we want to make sure we didn't change the value of our function. But we have to keep track of it somehow, so I took it outside the parentheses. Okay? This idea here is probably the trickiest thing that that we'll talk about today going into vertex form. If we have this number out front, we have to be careful when we complete the square. All right, any questions on that part? All right, let's look at another kind of example where we're kind of going a different way with our equation. Let's say we're given some points. We have a vertex, we have a quadratic function. The vertex is at the point 1, -2. And it goes through the point It goes through the point 3, 6. And we want to write the quadratic function in vertex form. So we're going to use this information to write our function in vertex form. So our vertex form, let's just write it down so we remember what it is. F of x equals a times x minus h plus k. So we want to write our function in this form. Well, we're given the vertex, so what does the vertex give us in our vertex form?
H and K.
Our vertex gives us h and k. This is h. I'm going to change my color here. This is h, and this is k. So let's write our function with h and k in there. We know that our function is going to look like f of x equals a times x minus 1 minus 2. So I'm just substituting h and k into my function. This 0.36, what does that tell us? What would that let us do with this function? What could we do with that 3 and the 6? Anybody have an idea? The x, and the 6 is a y value, right? So this is x and y. F of x, when I write in function notation, f of x is the same as y. So I can substitute these in for, and I'm just going to write that up there, f of x and y are the same thing when we're talking about functions in function notation. So I can plug those in. So f of x is 6, and that equals a times x, 3 minus 1, minus 2. So 6 equals a times 2, or 2a, minus 2. The 3 minus 1, 2, this should be 4. 3 minus, I'm sorry, 3, oh, x is 3. 3 minus 1 is 2, right? And then
2 minus 2 is
we still have a here. Yes.
Isn't it a parentheses x minus h squared?
Yes. Thank you. That's where I made my mistake. A times x minus h squared. Thank you, Travis. So 3 minus 1 is 2. 2 squared is 4. So I have 4a minus 2. Add 2 to both sides. So I have 4a equals 8. Divide by 4. And a equals 2. So now I can write my quadratic function in vertex form. F of x equals 2, x minus 1 squared minus 2. So I just use my points, use my vertex, and use the points, plug them into the equation, and solve for A. Yes, Kelsey.
Where did the 4a minus 2 part come from?
When I plugged x equals 3 in here, 3 minus 1 is 2.
Yeah.
2 squared is 4.
Okay.
So I'm multiplying A by 4.
Okay.
And the minus 2 is just from this one.
Yeah.
All right, questions on that? Okay. If we have a graph, if we have f of x equals x minus 4 squared, x minus 4 squared plus 5. What is going to be the minimum? What's going to be the minimum value? Where is the minimum of that function? If we have a parabola, if we have a graph of a parabola, and the parabola opens up, where's the minimum value of the parabola? At y equals, at what point at the graph do we get a minimum? The vertex. At the vertex, we get a minimum. So our minimum is going to be at the vertex. And if we had a parabola that opened down, the maximum would be at the vertex. The minimum of a graph of a parabola, graph of a quadratic function, is at the vertex, and a maximum is at the vertex if the parabola opens down. So our minimum or our maximum is always going to be at a vertex. So that I just want to remind you, when we're looking at a graph, or if the problem asks you for a minimum or a maximum, we're looking for the vertex. So the minimum or a maximum of a quadratic function is always at the vertex. So that's one reason why it's important, or why it might be useful, to be able to put our function in vertex form, is because a vertex tells us where our minimum and maximum value is going to be. So if we're given some kind of problem and it says what's the maximum value, where is the maximum of this function, the maximum is going to be the vertex. The x value is h, and the maximum y value is going to be k for our vertex. All right, I just want to go over one more thing, and then we're done for today. Another way to find the vertex from our formula, from our function. So if we have a quadratic function, f of x equals ax squared plus bx plus c. The vertex is going to be at, this is another way to find the vertex. Negative b over 2a is my x value, and my y value is going to be the function evaluated at negative b over 2a. So this gives me my vertex. This will be my h, and this will be my k. So just another way of finding the vertex of a quadratic function. We can use negative b over 2a to find the coordinates of our vertex. So let's look at a quick example of using negative b over 2a to find a vertex, and then we'll be done. So if we have, we'll do a nice simple one. F of x equals 2x squared plus 2x minus 1. And we want to find the vertex for this quadratic function. The vertex is going to be at negative b over 2a. Negative b over 2a is negative 2 divided by 4. So we get minus 1/2. And this is going to be h in my equation. And to find k, I want to evaluate the function at negative 1/2. So f of negative 1/2 equals 2 times negative 1/2 squared plus 2 times negative 1/2 minus 1, which is 2 times negative 1/2 squared is 1/4. 2 times negative 1/2 is minus 1, and we subtract 1, so I get 1/2 minus 2, and that's 1/2. 2 is 4/2, so I get minus 3/2. So my vertex, thank you, my vertex is going to be at,
So that's k.
that's k, and this equals k. So my vertex is going to be at negative 1/2 minus 3/2. Yes?
Does that mean the axis is negative 1/2?
Yes, so our axis of symmetry would be x equals minus 1/2. So this, using negative b over 2a, is nice when it's difficult to complete the square. It would be hard to complete the square on this one because we end up with fractions, and we end up dealing with fractions. So using negative b over 2a and f of negative b over 2a is a quick, easy way to find the vertex if it's more difficult to find the vertex form. So just another way to find our vertex is using negative b over 2a. Any questions? Okay, let me give you your homework. And we're on page page 116. And I wanted to give you one other quick reminder. Just we've talked about it. We talked about it a lot the first part of the semester. When we're finding zeros, some of the problems ask you about finding zeros. If we're finding zeros, it's the same as solving. Finding zeros, solving mean the same thing. Finding zeros is where y or f of x equals 0. So we're setting our equation equal to 0 and finding the x values where our function is 0. Finding 0, solving means y equals 0, means our function equals 0. Just wanted to remind you guys of that.